Hello and welcome back. And this is lesson 5 of Fluid 2000. And today I'm going to talk to you about cylinders and motors, or linear actuators and rotary actuators, which is what a motor is. Now, for the most part, most of what you'll be dealing with will be linear actuators. Hydraulics are specifically set up for good control of linear cylinders. We have a lot of different systems to make things of rotary action. So motors, a lot of the time now we're using stepper motors, or we're using other types of electrical devices to give us rotational energy. It's just easier and more controllable and less messy. However, if you're looking for a maximum amount of force with the minimum amount of mechanical effort, it's really hard to beat a hydraulic cylinder. So we're going to start there. So this is a single acting cylinder. This is similar to a car jack that you'd put underneath the fender of your car to change a tire. It has force applied in only one direction, and you'll see that on the symbol because it only has the one input at the bottom. The load itself, or gravity, will retract the cylinder once that valve had opened. So all you'd need on that is a directional control valve with bleed to tank and activate, and that would be all you'd need to control that. A very simple system, very robust, but limited in its applications because it can only go one way and the load pushes it back. Another variance on this is a telescopic cylinder. Now this particular one here is used, looks like, as a projection ram. These kind of cylinders are very useful in telescopic crane booms, for instance, is a great example of these. And literally, it's just a bunch of cylinders that are stacked in together. The thing about these type of telescopic cylinders and rams is they literally have a lot of seals on them. Every single one of those independent cylinders is sealed off from the one inside of it, kind of like Russian stacking dolls. It has the advantage of having a very long stroke, but very small when protracted. So I could have it literally go 50, 60, 120 feet in the case of a telescopic boom on a crane, but I can have it reduced to 15 feet when it's fully retracted. So the longer sleeves should extend first and slowly, and then the smaller sleeves will be extended more quickly, but with less force. And that has to do, of course, with the area. The area of the cylinder that's being acted upon by the fluid will ultimately give you your force, regardless of the pressure. So some small cylinders have spring returns, and you will notice there's a couple of videos there, short videos of me using a hydraulic cylinder with a spring return unit that is bolted on to the end to show you the difference in the force between two cylinders using the same flow and the same pressure, however, different size diameters, and it will demonstrate that to you quite clearly. But these cylinders will have a return spring. The turn spring will, of course, counteract that force, similar to a dead weight from gravity, and retract the cylinder. The amount of force applied can be controlled also by adjusting that spring. Because of Hooke's law and the fact that the further you compress a spring, the more it pushes back against you, can actually be a very useful element in that. So people will often mix the terms cylinder and ram interchangeably. Really, technically, if I'm looking at a rod, which is generally just a smaller diameter piece of metal that's solid, let's say 1/2 inch to 3/4 inch around, or 12 to 19 millimeters, that's generally considered to be a rod. A ram is a larger diameter. If the hydraulic cylinder that extends and retracts takes up of the area of the cap end, it then becomes more of a ram. And again, it has to do with the amount of area that's under pressure. So rams are generally considered to be a higher force. Okay, so here you have a double acting cylinder, and you can see the schematic diagram for that. It has 2 ports, and it exerts force during extension and retraction. Extension speed is slower while the force is greater, and again, that's because of the area. Retraction speed is faster, but while less force because of the smaller area. And it has piston seals for internal leakage between the cap end and the annular end. And it has seals, of course, around the outside to protect contaminants from getting into the cylinder itself. Okay. Sometimes you will have a double acting cylinder. These are used a lot on steering mechanisms for hydraulic lifts and those ideas. Really, they can extend in both directions with the same force and the same speed, which makes them excellent for a steering mechanism. They're generally not extremely high pressure devices because of the limitations and the fact that you will need to have some controls over how far they will extend. Otherwise, you can pop them through the casing. So it's important that the pressure on these, or the force on these types of cylinders, is limited, and you do have some kind of a limit system. And as you can see on the diagram here, it looks like they have 2 little limit switches, and those limit switches are preventing it from over traveling. Tandem cylinders. Tandem cylinders are not used very often, but they have an excellent ability to move a very large load in a very small package. And the reason for that is there's 2 inlets in the cap end and there's 2 inlets in the annular end. So you can push the fluid through and have that area of the cylinder magnified. So it's not a very big long stroke because of the internal limitations of it, but it's still extremely powerful when you need a lot of force in a small package. A lot of pancake jacks or low profile jacks are used this way to lift very, very heavy loads, but not very far. So a cylinder is a movable device. So as a result, it's going to wear, and it has a lot of parts. And most of these parts are serviceable. So if we're looking at it from the top, we have an exploded view, and on the bottom, we have a view where it's all put together. In the wind industry, which I'm familiar with, hydraulic cylinders aren't rebuilt on site, generally because of the size of them. The hydraulic cylinders that control blades on a wind turbine can be upwards of 3 feet long and weigh several hundred kilograms. So you're not going to be rebuilding them in a nacelle. You would be swapping them out. At the factory or in the shop, if you're working at a stationary plant, you will find that you will be doing a fair amount of this kind of maintenance. Most of the things that you will be replacing are going to be things like rod bushings, checking springs on ball check valves, and adjusting cushions and replacing cushions on cushion adjusters, which prevent the cylinder from ramming back into its home position or its extended position with too much force and wrecking the cylinder itself. As long as the O-rings on the piston seals are kept in good shape, and the wear bands, which are actually designed to be replaceable parts, they prevent gouging on the inside of the cylinder. And of course, the rod seal and the rod wiper are extremely important because the rod will be extended out into the outer environment, and as a result of that can become contaminated, and you don't want those contaminants coming back into your hydraulic fluid. As mentioned on the previous slide, a lot of times you'll have cylinder cushions, and those cushions will be at the end of the hydraulic stroke, and they're to prevent any kind of a shock that happens as a result of the force coming up against a sudden stop. A rubber bumper or some kind of a check valve mechanism that will prevent the cylinder piston from pushing up against a blanked head that it can't move. So if I push the joystick and I keep it fully extended, the pressure won't continually act upon that plunger. It will be relieved through the check valves. Sometimes they're just literally rubber stoppers or screws, or springs that prevent the cylinder from smashing up against its end of travel. A stop tube bushing is used a lot of the times to reduce the side loads on cylinders as they extend and retract. A lot of the diagrams show cylinders extending and retracting on a totally linear action, but usually with a cylinder, it is either supported at one end, both ends, or sometimes in the middle. And as a result of that, there will be some deflection angle and some side forces put on the rods and on the rams. So it's important that you have some kind of a stop tube and bushing arrangement that alleviates those stresses on the O-rings and pistons to prevent leakage. So cylinder mounting types, as mentioned, there are quite a few different ways to do it. They can either be fixed in the case of a true linear actuator, or they can be pivoted if it has some kind of a range of motion. And you will see that on bucket excavators and on lift tables and things like that, where it's either tied down at one end and is able to rotate through a certain number of degrees, 15 or 20 degrees, or if it's just linear actuated, it will just be straight up a linear motion one way or the other. Okay, here's some examples of fixed centerline mounted cylinders. So these ones are designed to push in a straight direction only. So if I'm putting this kind of a cylinder in, there's no real deflection. The thing is designed to just basically squeeze in one direction only. Very similar, very simple, and very easy to use. So if I have a non-centerline cylinder here, these are ones that have different brackets on them and different side lugs. And they will have some kind of difference in terms of how they stroke from the centerline cylinders. There'll be some deflection in that. Now here you have the pivoted cylinder mountings, and these ones can be on some kind of a clevis or a trunnion. There's no rigid support. These ones aren't fastened to the machine, but they're fashioned to a connection point which is allowed to rotate. And you can see here, going from left to right, you have the cap trunnion, which is literally, it holds the cap end down and allows it to rotate. The intermediate, which allows it to flex in both directions. Perhaps it's the cap that has to move through a 90-degree rotation, or the head of the cylinder itself. The long and the short of it is, this allows the cylinder to rotate back and forth through its motion, and therefore provide force directly on what you're looking for. So spacers, how to support my load. If I have a very large load, I might want to support it in more than one or two areas. I might want to support it in the center as well as on both ends, or I may need to space it for gaps. And that is used a lot on long stroke cylinders or telescopic rams, because we need that to be a linear motion over a long distance. And any deflection can result in damage to the actuator and leaks. So these again are mounts. And again, you can see on the machines, the clevis mounts there. It allows that device to extend and tip it back and forth. So it makes it for a lot of, gives you a lot of options in terms of applying force in a straight line. You can still use a bit of an arc, and that's by using literally the flexible mounting systems. Now, again, as noticed or as mentioned, that you do have some cushioning there for your cylinders when they reach the end of stroke. Another way of doing this, particularly in a bidirectional cylinder or in some kind of a sequential operation, is to use some kind of limit switches, and be them mechanically or electrically operated. Electrically operated limit switches now are pretty much used. The reason is it's much easier and cheaper to use them than it is to plumbing and piping pilot lines to fluid roller cam or button switches in the case of pneumatics. If I can use a proximity limit switch that is electrically operated, coming back to a PLC, I can also change the programming of that particular machine so I can vary its stroke pattern. For instance, if I had a robot that is welding cars, I could have it programmed to weld the frames of Toyota Camrys on Tuesday and Toyota XLs on Thursday by simply changing the program, and I wouldn't actually have to change any of the plumbing of the fluid. So you'll find that the proximity switches are used a lot. And a lot of times they'll use the magnetic tip. And as that cylinder goes by and the piston comes up close towards where this proximity switch is mounted, it will flag it. So here's a couple of things to think of when you're taking cylinders apart and putting them back together. And that's something that a maintenance mechanic in a facility will do quite often, or you will need to diagnose if there's any problems. Moving parts wear out. Pitch cylinders, for instance, in a wind turbine are very frequently under very heavy loads, under small travels too. Even though that piston ram can travel 90 centimeters to a meter, generally it has a parked position, and then its running position is last 10 to 15% of the travel of the cylinder, and it will go back and forth between them. As a result, you can get some wear on the wipers and on the rods themselves. So there's been some unique ways of dealing with that in older models, including putting trunnion mounts on the cylinders to give them a different stroke. So now they're stroking in the middle of the cylinder as opposed to the end. So it's very important that the wear rings and the seals are checked, and this has a lot to do with fluid cleanliness and type too. You can really mess a system up, as we mentioned before, by changing the fluid to an incompatible type and wrecking all of your wear rings and your seals and your O-rings on your existing equipment. So some cylinders will have a bellows covering the rod or the ram, and those are designed to keep dirt out in very dirty environments. You'll see that a lot in excavators or moving equipment that's dealing with dirt or water. You must remove these to check for leaks, and the reason is you'll get a crack on one of the bellows, and water and dirt will get in, and it's trapped inside there, and it will sit up against the seal, because as the cylinder strokes in and out, it will wipe it down to one end or the other, and it will start to corrode the cylinder ram or rod at that particular point. And as that rust is drawn over the seal, it acts like sandpaper and wrecks the cylinder's sealing ability, allows dirt and rust to get in, water to get in, and fluid to get out. So it's just a big mess. Keeping your cylinders clean and functioning properly is extremely important. All right, that should do it for cylinders. Again, watch the two videos that I've included here that show you the difference in diameter and its effects on the amount of force. And we'll talk to you next time for rotary actuators or motors.